The first step in every hypothesis testing is actually formulating H0 and H-alternative hypothesis. When do you need hypothesis test? Let's say you make a survey analysis and you collect a sample, and of course you want to say something about the whole population and the whole target population, and of course there is a lot of uncertainty when you only have a sample which is a small fraction of the whole population. So a hypothesis test is actually taking care of this uncertainty. So the first step in every hypothesis testing is stating null and alternative hypothesis. No matter if it's a one sample, two sample test, is it for t-test, z-test, chi-square test, whatever, state null and alternative hypothesis is the first step. And when you make some calculations, choose appropriate test statistic, find p-value, and at last make a conclusion. So I have underlined step A and step D, as I think it's nowadays it's maybe the most two difficult steps in hypothesis testing, because step B and C basically is done by software. You just have to choose the right method. You just have to choose the right method. So stating hypothesis, it's about two claims. You want to evaluate two mutually exclusive claims about one or more populations to determine which claim is most true on the basis of a sample drawn from the population. Definition given by every statistical book. So two claims. Let's say you collect a sample of 71 respondents and ask them about their satisfaction with their bank, and ask them which bank they have. And let's say you want to study if customers at some bank, let's say in this case Danske Bank, are less satisfied than customers in other banks, because this bank had some problems, issues, so maybe customers are less satisfied than customers in other banks. And you see here that in this bar chart, the average satisfaction rate, and the satisfaction question was on a Likert scale from 1 to 5. The average satisfaction rate seems a bit lower for Danske Bank customers. Average rates for people in other banks is 3.87, and average rate at Danske Bank is 3.26. So it seems like it's slightly less satisfaction in Danske Bank than in other banks, but it's only a sample of 71 people. And so we have to state two mutually exclusive claims, and first claim would be that Danske Bank customers are not less satisfied than customers in other banks. And the second claim would be Danske Bank customers are less satisfied than customers in other banks. So those two claims has to be mutually exclusive. So if claim 2 is true, Danske Bank customers are less satisfied, then claim 1 is not true, Danske Bank customers are not less satisfied than customers in other banks. But we need to state it more precise with inequality signs. So think about claim 1 as a null hypothesis, as a status quo where there is no difference, nothing happened, same size, whatever you are studying. Claim 2 is something that you have to prove, that needs to be proven, that there is a difference, that one parameter is actually different from another parameter. Let's say mean value is lower or larger or different from some number. So let's take another example. My financial advisor wants to know if the average expenditure on food per month has increased since the last year, when it was 2,630, say, Danish kroner. And she draws a sample of 25 random families and finds out that the average expenditure on food per month this year is 3,100 Danish kroner. Do we need a hypothesis test at all when it is obvious that 3,100 Danish kroner is clearly more than 2,630. And the answer is, of course, because it's only a sample of 25 random families. So how to state null and alternative hypothesis? Again, convert the research question to null and alternative hypothesis, two different claims. So null hypothesis is claim of no difference in the population, a status quo. There hasn't been any increase. An alternative hypothesis is a claim that H0 is false, that actually there has been an increase in the average expenditure. So sometimes it's maybe helpful to start by stating the alternative hypothesis, the one that we have to prove there is a difference, and then the H0 would be just the opposite of it. Again, it has to be mutually exclusive hypothesis. So it translates to claim number one, or H0 hypothesis: the average expenditure on food per month this year is equal or even less than 2,630 Danish kroner, and claim two is, as is our alternative hypothesis, the average expenditure on food per month this year is greater than 2,630 Danish kroner. Did the average expenditure on food has increased compared to last year, and this is our H0 and H alternative hypothesis, the first step of every hypothesis testing. And actually you can make three different hypothesis tests depending on if you want to prove something has increased, decreased, or there is a difference. So you have something called two-sided test, when H0 is just in some population value is equal to some value, or is it different in alternative. And when you have those two options, one-sided test as we call, when alternative, when you want to prove something is less than some given value and something is more than some given value. Anyway, there is a practical reason for stating hypothesis as a first step, because nowadays every statistical software where they will present all the three tests at once when you insert the data, and you have to choose the right one that answers your research questions. Therefore, you need to state H0 and H alternative before making any calculations. Then it's much easier to choose the right answer. So here come some exercises, and just feel free to pause them and state your hypothesis, and you can compare to the answer I will give you afterwards. So the problem is, let's say as a fast food restaurant manager, you want to determine if the waiting time to place an order has become shorter since last month. And the question of interest is the current time shorter than the last month's time, which was 4.5 minutes? So what is the null hypothesis and what is the alternative hypothesis? So you have to insert the correct inequality signs, and just pause the video, look at this table, and choose the right inequality signs and insert them. Which one is right? So just pause the video and I will continue shortly. And this is the answer. And here is another exercise. Let's say a random sample of students was collected, first year students, and let's say I believe that the average age of students is 21 years. So if we put this claim to test, what would be H0 and H alternative? Null hypothesis and alternative hypothesis. Just pause the video and then continue again. The null hypothesis becomes that the average age is equal to 21, and the alternative is the opposite one, that the average age in the population of students is not equal to 21. And let's see again, H0 always is that there is no difference. It always contains equality sign, always. So alternative is always about the difference, not equal to, less than, greater, more. Let's say we do test with proportions. And with proportions, it's the same procedure as with mean values when stating hypothesis. You just have proportion and not mean. And let's say you have a situation here that a CEO at some bank says that if the share of customers who made a complaint about the service is higher than 5%, we have to do something. And assume that P is the proportion of customers that made a complaint. So what do we have to prove here? So you pause the video and you continue afterwards. And the right answer is, this is our H alternative we want to prove. H0 is the status quo, that the proportion is not above 2%. Again, it has to be two mutually exclusive claims. And this is it.